This conference will now be recorded.
Okay, so good morning once again, and welcome back to the session that is Big Data Masters program, and we are going through with distributed processing with PySpark, and we have started the cloud uh, cloud part as well. So with respect to cloud, we have started AWS, and that is Amazon Web Services. And from the AWS side, in the previous session, what we have seen how to create EMR cluster, how to create EMR cluster. So EMR cluster, that is Elastic Map Reduce. Elastic Map Reduce, the cluster we have created, and we have created it with GUI. So let me open the AWS console. So this is the AWS console what we are having. Okay, and let me log in into the AWS console, sign into the AWS console, and click onto the EMR, and we will be able to see the EMR cluster, that is Elastic Map Reduce. Okay, so over here, with the help of GUI, say if you want to create the cluster, so you just need to click on create cluster, and you will be having these particular options, and we have created from this particular option. But if you want, you will be able to create this particular cluster through the command line as well. So how you will be able to create it with command line? Let me copy this particular, let me click onto this particular cluster, and inside the actions, what we will be able to see the command which is used in order to create the cluster. Let me copy and paste it over here. Okay, and just have a look. So this is a command AWS EMR create cluster, and the cluster name is data engineering cluster, and log URL, that is where the logs will be stored for this particular cluster, and which release of EMR we are going to use, then which one is the service role, okay, IAM role, and EC2 attributes. So we are going to have certain EC2 attributes wherever, like we are having the master security group and the slave security group as well. Then what are the different application I want to have? So HBase I want to have, Hadoop I want to have, Hive I want to have, Hue, Jupyter Enterprise Gateway. These are the application basically what I want to have in my cluster. Then configuration, what will be the configuration with respect to the configurations, like for the hive site we are having properties. For hive we need to maintain the metadata, so hive meta store is there, and we are having glue meta store, glue catalog as well, and which is utilized in order to, you can say, maintain the table and all, or maintain the metadata. So catalog is used, glue and hive catalog is used to maintain the metadata. Then instances, instance count one, and that is of master, one master I need to have, that will be the primary node, and the type will be mx large, and EBS configuration, so EBS storage type is utilized. We will be discussing in today's sessions what is the EBS storage, and then the size and all. Okay, so instance, then how many instance I need to have, the core instance, so two core instance I'm going to have, and what will be the type for these core instances, that will be C5.2x large, and the configuration and all ABS, the storage volume will be of ABS type, and then the volume types, that is 32 GB RAM, and two instance will be there, and optimized, yes, it is optimized one. Then scale down behavior, terminate at task completion. So once the task is completed, the this will be terminated. ABS root volume, this is the 50 GB which is used in order to uh, in order to maintain the OS and other required application. This is, you can say, operating system space basically. Auto termination policy. So if it is idle for 3600 seconds, then the cluster will be terminated automatically. And OS release, this is the operating system and region, in which region I'm going to create this. That is perfectly fine. Let me copy this and then open AWS console once again and sign it to AWS console. And over here inside the AWS console, I'm going to open Cloud Shell. Okay, Cloud Shell is the service which is providing you the command line interface. Okay, and what you need to do over here, you just need to paste that particular command and the cluster creation will be started. So I'm going to paste that particular command. Okay, it has been pasted. Okay, paste it and press enter. Press enter. Okay, now the cluster ID is this one and the ARN is this one. So just have a look onto the console, EMR console, and just you will be able to see the cluster has been started. A cluster has been started. Now how we have done this particular stuff, we have just pasted a particular command onto the PowerShell, Cloud Shell, and then with the help of the command we will be able to create the cluster. So this particular cluster creation will take certain time. Now we will be going to discuss about certain things. Inside the cluster creation, what we have seen three types of node: master node, core node, and task node. Master, core, and task. Let me show you through the GUI as well. So over here, let me try to go into the cluster and say click onto the clone. I just want to clone this particular cluster and let me go into the configuration whatever we are having now. So in this particular cluster, what we are able to see, primary node, that is fine now, that we have mentioned over here, primary node, primary node, primary node, primary node, core node, and task node. Three types of nodes are there. Then what we are able to see, core nodes we are able to see, and the third we are able to see the task node as well. We have not configured the task node over here. Let me proceed without cluster creation and click onto the create and just have a look over here. So primary node, core node, and task. Just have a look onto the task. Task one of one. So task node, three types of nodes are there: primary, core, and task. And with respect to the instances, we are having three types of instances, that is on demand, spot, and reserved. We have seen in our previous session. So primary node, it is denoting, it is denoting where master is running. Master is running. Okay, now with primary node is nothing but master. So master will run over here onto this particular node, and it will be the master of this particular cluster that we have created. Then core node. So core node over here, inside the the core node, we will have we will have will have the capability to host data and process data. Okay. So core nodes, onto the core nodes, what I can do, I can store the data and I can process the data. Try to recall the Hadoop concept. Inside the Hadoop, what we are having name node. Name node is nothing but the master of the cluster. Then we are having data nodes. Data nodes are nothing but the slave nodes where we will be having the data, and those data nodes are utilized in order to process the data. That is also fine. Now core nodes are the same where we can host the data and process the data. This is the main thing, host the data and process the data. This is the capability of core nodes. Then what is the meaning of task node? So what do you understand by task node? Anyone? What is a task node? We have seen inside the EMR cluster, we are having task node as well, the option for creation of task node. But what is a task node? What is a task node? Okay, let
Executor
me
node.
explain. Yes, yes, yes.
So it's, I think like it's equal to your executor node, which will be performing the task assigned to it.
Yes, but what is the difference? Core node is also performing the task, or is going to execute the task. Difference between core node and task node. Both of these two are able to do the execution. Task node, let me explain. These are ones which can't, which can, which can run task, but it can't host the data. That is the main difference. Over here, the core node is able to host the data, but task node are not able to host the data. You can say nodes without storage. Nodes without storage. These particular nodes can be utilized for the processing perspective. You can think in this particular way. Say you are having a cluster, and that particular cluster is utilized in order to process the application which requires a lot of executors, or where we are having heavy compute applications. At that moment we can add certain task node as well. Over there we are nothing like storage and all, but we are having certain nodes in order to process only, and once the processing is done, then the output will be shared. So over here we are not having the capability of hosting the data, but we can process the data. We are having executors over here, and those will be utilized for processing the data. That is perfectly fine. Primary, core, and task node. Let me check the status of that particular cluster what we have created recently. Okay, it is still starting. The cluster is still starting. Okay. Now, what we are going to discuss, going to discuss another topic, that is transient versus long running cluster. Okay, we have created a particular cluster. Then which one type of that particular cluster is from transient versus long running cluster? So transient cluster and long running cluster. Long running cluster. So transient cluster, it is once the task is completed, then the cluster will be terminated. Terminated. So that is terminated automatically. What I can say automatically. Okay, that is nothing but transient cluster. And over here, okay, over here, say it is asking say auto termination policy. Yeah, so auto termination policy, once we are going to submit the task, then we will be able to see say if the job is failing or if the job is completed, then what you need to do, you just need to terminate the cluster. That will be nothing but the transient cluster, it will be automatically terminated after the completion of task. But what is with respect to the long running cluster, it will not be terminated as the name indicate itself, like it will be long running cluster, and post job completion it will keep on working. Okay, so that will be long running cluster. Transient versus long running cluster, transient cluster will be terminated automatically after the completion of a particular job, task or application. But long running cluster, with respect to the long running cluster, it will be keep on running after the termination of job, after the completion of job. Then what we have seen the storage type as well. Storage type, storage types. So with respect to the storage types, or storage levels, I can say, storage levels, storage levels. Now we are having three types of storage levels: instance, instance store. Okay, so what is the meaning of instance store? This is tightly coupled with the instance. This particular store, this particular storage is tightly coupled with the instance. Once the instance is terminated, then this particular the data which is stored in this particular storage, that will be gone. Let me mention over here, this is tightly coupled with, this is tightly coupled with instance. Once the instance is terminated, then this particular storage, no, then the data that is stored in this particular storage, that will be gone. Okay, tightly coupled means say we have created an EC2 instance. EC2 instance we have created, and EC2 instance is nothing but that will be having certain core plus memory plus storage. And storage that will be uh, locally available in that particular machine. You can think like uh, like my computer, my laptop. So in my laptop, if something is there and I have given it to someone, if I'm going to format and if I'm going to terminate this particular machine, then whatever is there, that will be gone. So over here, with respect to this particular instance store, it is tightly coupled with the instance that you are going to create. Once you are going to terminate that particular instance, the data will be gone from there. So that is instance store. Second type of store, that is S3. S3, that is simple storage, a simple cloud storage service. Service. Okay, simple cloud storage service. This is something like this. Okay, and what I can say, this is cloud storage, and you can access data from here in order to perform operations. Okay, now we will be going to learn, we will be going to see one application. We are going to put certain data on S3, then we will be having an EMR cluster. Okay, and once the processing is done from EMR cluster, then the data will be moved from S3 to EMR, and once the processing is done, then again that particular data, process data, will be moved from S3 EMR to S3. S3. Okay, so data, that is input and then processed data. Okay, or what I can mention, say raw data. Raw data. Okay, so what we are having onto the S3, I can store certain data, raw data, and we will be having a particular cluster that is going to process that particular raw data. And once that particular raw data is processed, then it will be moved onto the S3 again. So over here, what we are doing over here, we are reading the data from external storage. The EMR cluster, the data is not available locally inside the EMR cluster, so it is not having the benefit of data locality. And this is the main, you can say, concept, data locality. If the data is not locally available inside the EMR cluster, the movement of the data will take time and the job will be non-performant. At that moment the job will be non-performant. So over here inside the instance store, we are having data locally available, but once we are going to terminate this particular instance, the data will be gone. Over here the data is not available locally. Okay, if we are terminating the cluster, the data will remain there. It will not be deleted. Just have a look over here. So previous one, the instance store was having an issue that if the instance is terminated, then the data which is available in that particular instance, that will be gone. Then second one is S3. So what S3 is saying, data will be remain on S3, raw data or process data, and once we are terminating this, okay, the cluster will be terminated but the data will remain safe. With respect to the data, that is fine, but once we need to process the data, we need to read it from S3 and we need to write it on S3 after processing it. So this particular transition with is going to add certain latency. Like movement of the data from S3 to cluster or cluster to S3, that will take certain time and jobs are non-performant at that moment. Now what we are having EBS storage, EBS storage, that is elastic block storage, storage, elastic block storage, and we usually call it network attached storage, attached storage. Okay, network attached storage. So network attached storage, over here, what will happen, say, once the cluster is terminated, once once the cluster is terminated, then it is asking us, are you willing to retain the data? So if you want to retain the data, then you can move it on to the S3. And if you don't want to retain the data, then you can delete that particular data. So EBS storage is the mixed version of EC2 and S3. And over here, we are having the benefit of data locality. Data will be available locally in the system, EBS storage. And once the cluster is terminated, then it is asking us, are you willing to retain your data? If you are willing to retain your data, then you can move it onto the onto a particular location. If you don't want to retain, then you can delete that particular data. Okay, you can keep it as it is and it will be deleted. So these are the three storage types inside the cloud: instance store, S3, and EBS storage, EBS that we are having in this particular cluster, EBS storage what we are having inside this particular cluster. Now the cluster is inside the waiting state, it has been created, and now we will be able to run the application over here. The cluster is up and running, and just have a look. These are the properties of the cluster. Bootstrap actions we have not added. The instance, it is having one primary instance is there, and two core nodes are there, one primary instance is there. And task node we have not added because task node are having not having the benefit of this particular storage, inside the task node you will not be able to see this particular storage, on demand. These are the on demand resources. And EBS, so just have a look, EBS size, that particular volume will not be available into the task node, and EBS, that is the same storage what we have mentioned over here, EBS storage. So this particular storage is working in such a way, once we are going to delete this particular cluster, although like once we are deleting this particular cluster, it is going to move the logs onto this particular path, we will be able to see the logs. Okay, so log destination in S3, with respect to this particular cluster, the logs will be moved on in this particular directory, let me try to show you, okay, so node, and so this is the cluster, that we have created in let me open another console, another window, and and go inside the EMR. And what I want to show you, I just want to show you, say, elastic map reduce, and it will be having the cluster, all the cluster information whatever we have created. Okay, and you will be able to do the analysis which job was running in this particular cluster. Okay, what was the status of that particular job, just have a look. These are the clusters what we have created, uh, 2EBHSQW1C, and that is the initial one, say YNQ089, YNQ089. Okay, this is the current recent one, YNQ089. This was the terminated one, YNQ089. So all of these particular cluster will be available over here. We are having 11 objects over here, and almost 11 objects will be available over here. If you are going to count, these are 11. 1, 2, 3, 4, 5, 6, 7, 3T, 8, 9, 10, 11, 12, 13, 14. Okay, so with respect to these particular names and all, probably like these four are not available. Okay, but what is happening, it is going to ask us like, do we need to retain our data, and it will be automatically retained in this particular path. We have not mentioned, it is automatically taken, and the data with respect to our jobs what we are going to run over here, it will be retained over there. So this is the path of the logs what we are going to have. Now bootstrap action instance, we have seen steps. Nothing is inside the steps, these are the applications. Now let me connect it with SSH. So we are going to copy this, and let me start putty. We are going to paste this particular host, and then copy this particular key, and okay, so we need to, it will be network failure because we need to add, the IP has been changed probably, so we need to add this particular IP into the security group. Okay, so network connection timeout. So what I need to do, I just need to change the configuration of in inbound and outbound roles. So over here inside the security group, properties, I will be having the master and the slave. So VPC, not VPC, security, security configuration, instance configuration, monitoring, event tag. I'm looking for the security information. Okay, over here only. Yeah. So security groups, firewalls. So this is with respect to EMR managed security group, and if I'm going to click it, it will be going to show me the configuration with respect to the master, elastic map reduce master. So inside the master, what I need to do, I just need to add certain rules, inbound rules, and I just need to add, connect it with SSH with my IP. It is going to take my IP, and I just need to add TCP IP, say my IP, and ICMP, sorry, TCP, all TCP, add rule, ICMP, my IP, version 6, that is fine, add rule, ICMP6, my IP, and all traffic from my IP. Okay, perfect. Save rules. Rule has been changed. Same I need to do with the slave. So this is for slave and it has been opened. Now what I need to do, I just need to edit the inbound rules, and same configuration I just need to add over here now. So I can change it over here, my IP. It is going to change my IP. Okay, cancel, edit inbound rules. Let me add it. It will create problem otherwise. SSH, my IP, then all traffic, my IP, then all ICMP, my IP, and version 6 my IP. Perfect. Let me do the changes. Okay, now I am going to open putty again, copy that particular stuff what we have seen over there. Authentication, I just need to uh, click the private key, provide the path for private key, open, and I will be able to connect with putty. Okay, so what we are able to see over here, we have seen public key, public key, and private key, private key. Okay, so public key and private key. So once we are having private key or public key, say, so public key that is used for transfer data to and from AWS to outside world, outside world. Okay, that is the use of public key. And with respect to the primary key, that is data transfer within the AWS. Data transfer within the AWS. So for this, we just need to have the AWS key. Now we, with the help of the key that we were having, that is data engineering cluster key, what we have created. Okay, over here only it has been placed. So we have connected with the cluster. We have connected with cluster. Now that is fine. Now we are able to connect with cluster. And in the previous session, what we have seen, how to execute a simple job over here. Now moving further, what we are going to do, say we are having certain code. Let me open. Okay, Titanic test.csv output. We can take this one. Okay, Titanic. I'm going to check certain data. Okay, so let me try to open PyCharm, and inside the PyCharm we are going to write down certain code, and then what we will do, we will execute that particular code onto the cluster as well with Spark submit. So, uh, huh, Titanic. We can take this Titanic example as well, but let me proceed with the new one. Uh, huh. And this is the Python file, and it will be say week 16 day 26. Okay, distributed processing. Okay, let me write this one only, distributed processing. Perfect. So what we are going to do, we are going to read a particular file, then do certain aggregation onto top of that, and then we will try to do the execution of that particular job with a EMR cluster that we have created. Now what I can mention, say from pyspark.sql, we are going to create the session sql import spark session. That is perfectly fine. We have create we are having a we have imported the spark session. Now let me create a spark session, then spark session dot builder, and what I can give an application name, dot app name, and with respect to app name I can give an application name, say cluster trial, cluster trial. I'm going to run the application on cluster dot get or create. Perfect. I have created a spark session. That is perfectly fine. Now what I'm going to do, I'm going to read a particular file, and which file I want to read. Okay, let me proceed with the flight data, and this is the file that I'm going to read, small flights, and this is the path for that particular file. So small flights, DSDS flights, flights df, small flights df, and what I'm going to do spark dot read, and I'm going to leverage dot format is of CSV type for that particular file. Perfect. Then dot header information. So header is true, header true. Perfect. And infer schema dot option, and infer schema true. I'm going to move with the schema that is that will be defined by spark true, true, and I'm going to say use option, and path I am going to provide, and path of that particular file is this one. Let me paste it over here, and this, and we just need to change it inside the spark understandable format, and that is inside the flights data I'm having this particular file, flights underscore small dot csv, dot csv. Okay, dot load. Perfect. And let me try to show top 20 records from that particular file. So I have I have created a Spark session, and from that particular Spark session, I have read a particular file that is small flights underscore CSV, and then I try to list top 20 record from that particular file. So we just want to do certain things inside this. Okay, in order to keep it busy, otherwise it will be terminated. If it is waiting for 2 hours, 1 hour, 600 seconds, then it will be dropped down. It will be terminated. So we are able to read the data of that particular file. Okay, so small flights data we are able to read. Now we are going to read the planes data as well, which is available over here. So planes information is available over here as well, and what I can mention, planes df, and planes df dot show, and instead of this I'm going to have planes. So these are the two, you can say, data frames that I will be having, and I just want to performing the joining of these two data frame. And this is a what I used to say, Spark application is having three main phases. Say reading data, then reading data is fine, then we are going to do with move with processing data. Now we are going to process, say we just want to perform the joining, and say I'm having join df, that is join data frame, and what I want to do, flights, small flights df dot join, and I just want to join it with planes df, and where where small flights df. So inside both of these two data frames, what we are having, this tail num is the reference point, and we can do the joining based upon that particular reference point. We have gone through with this particular example, so um, I'm moving of in a little bit, you can say, high speed. So small flies df equal to planes df, and this particular column which is as a reference point, and what I can have, the join type is a inner join. I just want to apply. So join df dot show. Let me try to visualize dot show. Okay, so it is going to join this particular data frame. Now what I'm going to do, this is the processing area. Now writing the output. Writing the output. Okay, so in order to write the output, that is, say, join df dot write, and what I can mention, so that is with respect to join df. Both data frames has been joined together. Now join df dot write, and what I want dot mode, what it will be mode, I can say overwrite. We are having three modes, we have gone through with this, and format, that what it will be format, I want, say, csv format, and then option, I can pass the path, and the path, what I can mention, I can give this particular path as well, because I have used the overwrite mode. Overwrite mode will take the path which is the existing one. And what I can mention, say, output. Okay, output, that is the path. And let me change it into acceptable format. Okay, acceptable, writing the output. Perfectly fine. And I can add certain more clause over here as well, but let's move with the this particular clause. I can have the compression as well, I can have the partitioning and all that particular stuff. So let's move further. So over here I just need to use dot save. Save. Perfect. I will be able to write. So I have started the execution, and okay, the execution is keep on going. Okay, so what it is saying, exception column. Okay, so okay, I got the issue. So over here in this particular data frame, what we are, this is join df. This is having tail num. Two similar columns are there. Two similar columns are there. So what I need to do, I just need to drop a column. And how I can drop? So I can utilize, say, join df dot drop and not na. I just drop, and what I want to drop, tail num I want to drop. So tail num, and I can mention it over here. Say final df, I can pass it over here. Okay. So join df dot drop and tail num I'm going to it is going to drop both of the columns. Just let me check. Let me check and join df dot show. Okay. So let me check it first. Drop. Is it going to drop both of the columns or the single columns? Drop can drop is going to drop function is going to drop a particular column from the given data frame. So I just want to check, like, is it going to drop both of the columns or the single column will be dropped down? So just have a look over here. We are not able to see tail num. Okay, it has dropped both of the columns. It has dropped the both of the columns. But I don't want to drop both the columns. I just want to keep single column, single tail num column. So in order to calculate the in order to calculate the unique column, so we can move with a particular function or code, say unique column. What I can have unique call, and what I can do, I can pass it from a for loop, say for call in join df dot values dot columns, and if this join df dot columns dot value dot count and count of call I can have, that is equal 1. I can have what, that is unique column, and I can create a unique column. Final df, I can create final df, and that will be going to do what, join df, and I can pass dot select this particular stuff dot star unique columns. Okay, and final df, I can write the final df at this moment, and say final df dot show as well, and let me. Okay, so what I have done over here previously, df dot drop, join df dot drop, what it has done, it has dropped all the tail nums. Two columns were there with name tail num. So in order to calculate the unique columns, what I have done, for call inside the join columns, if the join column count equal 1, so that will be taken, that will be passed to the unique column. So that particular count will be taken, and based upon that I'm going to create the unique column, and then I'm going to write that particular final df onto a particular path. So the execution has been started. We have gone through with this particular stuff in our previous session. No need to worry. So the execution has been started. Okay, and the execution has been done, and now we are having, say, here was turbo, that is perfectly fine. Still it is showing that particular stuff. Okay, leave it. So what we are going to do,
Sir,
so
maybe
yes, yes,
because
yes.
when you said unique column count equal to 1, Telnum is 2 already. So Telnum again got dropped.
Yes, yes, it is again dropped down. It is again dropped down. So we just need to like check it with respect to the another method. That will be done, no need to worry. Like if you want to keep single column, so we can keep it, but the main motto over here is to do the execution of this particular code with the EMR cluster. The main motto, we just want to run that particular code over here. So 4 plus 5, so what we need to do, if we just want to write this particular code, let me copy and start a notepad. So this is the code that we have written in order to join two data frames, and based upon that particular data we have performed certain operations, and after performing that particular operation we are trying to write it onto a particular path. So this is the code with respect to that only. Okay, so over here we are having this particular data. Now what we are going to do, we are going to this particular path on AWS. So over here we are reading the data from local and writing the data on local. So first we just need to change this particular path. And what do we need to do over here? We need to go on inside the S3. Inside S3, what we are having, we are having certain data. Okay, so these are certain buckets what we are having, and okay, booster analytics too. Say this is the data, and over here we are having flights data, and inside over here what we are having, flights small flights underscore small CSV, and these two files are there where we have performed the join, on which we have performed the join. Now copy URL, and what we just need to do, we just need to change this particular path. Let me change this particular path. So this is flights data. Okay, perfect. So this is the path for flight underscore small dot csv, and this is the path for planes dot csv. Planes dot csv. Perfect. And we are having this particular path. Now, after like processing, where we are going to store, we are going to store it over here only. Say inside flights data, and the path will be one folder will be created with output name. Perfectly fine. So that is the change what I need to do in this particular code. What else? So import pyspark. Import pyspark. Okay, that's it. Each and everything is fine. Let me try to save this particular code as a Python file. All files, and I am going to paste it onto the big data factory over here, and over here, and let me give a name, say uh, testing code .py .py, and save it, and testing code.py. Okay, so testing code this .py, I just move this particular file from here, uh, and over here I'm going to paste that particular file now. Okay, testing code.py. Perfect. Let me upload this. Okay, it has been copied. Now what I just need to do, I just need to copy this particular path, copy URL, and I just need to go into the EMR cluster. This is the EMR cluster what I'm having, and over here inside this particular cluster I just need to go inside step and add step, and what I'm going to do, I'm going to run a Spark application. Okay, let me have the old console. I just want to move with the old console. Old console is having certain good visibility. So this particular cluster steps and add steps and Spark application, and just have a look over here. The name of Spark application, you can give any name, say first program, first cluster execution, and the mode you can choose, and you can provide certain options over here, and then you can paste that particular path for that particular Python file. Action on fail, if the job is failed, then we are going to continue with the operation. Click add, and then you will be able to see like this is the application, first application that you have executed. Okay, pending, it will take some time, and meanwhile where we can check it, I can go onto the monitoring application interface and history server. I just go on to this particular history server in order to check this particular application. Okay, Spark UI. So application, so PySpark shell. The application is not came yet over here, and steps. Okay, so it is in running state. If it is running state, then probably we will be having the application name like my first application over here. So cluster trial, that is the application probably what we have. Okay, so this is the application name what we have given in this particular code, app name, cluster trial. So cluster trial, it has been picked from that particular code. Execution running, it is running in running state. Okay, the application is running. So what we have done over here, locally we have done the execution of this particular code, like that is joining of two data frames, and then sharing the output onto a particular location. And over here the same thing what we are doing onto the cloud. So it is keep on executing, and once the execution is done, we will be able to see the outcome onto the cloud location only. So it is keep on executing, and over here inside the history server, with respect to this particular application, that is cluster trial, we will be able to see the steps and all. So load the native data, so it is loading the data, and we will be able to see the steps, we will be able to see the environment and all. Okay, all of these particular informations are available with respect to the cluster. We will be having a discussion in detail with respect to each and every component which are available in the Spark UI. This is nothing but Spark UI or history server. Once we are talking, uh, if we talk about it on the AWS. So on AWS, we are having Spark UI as history server. Now execution is application is still running. Okay, application is still running. So it is still running. The data is very small. Still it is taking too much time over here on cloud. Running. Mm-hmm. It is taking, why it is taking too much time? Okay, so show we have used df dot show. Hmm. Okay, it will be executed. Not an issue. It will take some time.
Ashokji,
Mm-hmm.
meanwhile,
Yes.
can you please recall all the steps again? Like, what are the steps you have taken from starting to end till?
Okay, okay, okay. Give me a minute. Give me a minute. Okay, so what I can do, I can remove certain unwanted stuff. Say find df dot show, planes dot show, in order to make it a little bit performant over there on cloud dot show, and perfectly fine. I can remove this particular for loop as well, just by final df equal to join df dot drop and drop say tail num. Tail num final df and final df dot save as.
So one more show
Mm-hmm.
command is left right above the tell num.
Okay, okay, okay.
Yeah.
Thanks, thanks. Okay, so we are going to make it a little bit more performant. That's it. So, perfectly fine. It is still running. uh, save as and all and Python code new, what we can say dot py. Okay, perfect. Now Python code dot py, we just need to upload it over here onto the S3 location and upload, add file, Python code new, and upload. That's it. And what we are having Python code new, we just need to paste this particular path, copy this particular path, copy URL, go inside the EMR, and we can add more steps over here. Spark application, say cluster mode, that is fine. This particular new application, add on. Okay, so new application will be keep on executing. Okay, so and meanwhile let me show you how the execution can be done onto the terminal. That is the this is the uh, hmm, open with notepad plus plus. So so over here onto this particular EMR, the Spark session is already available. If Spark session is available, so there is no need to create the Spark session. We just need to proceed with reading the data and then processing it and then finally sharing the output. Let me copy this over here. Load, that is perfectly fine. It will be loaded. Okay, so it is taking some time. It will be loaded, not an issue. What is the issue onto the cluster? What is that one? Okay, so the configuration is very less onto this particular cluster. So let me try to resize it to 4 machine or resize it to 4. So over here, I just need to have 4 instances. And for requested, it will take some time. Then I will be having enough resources in this particular cluster. Resizing is being done over here. Steps still running. It is not taking the other another steps. Okay, it is not taking the command. A cluster is not taking the command. So wait for a minute. Then we will be having that particular 4 nodes over here, and monitoring. Inside the monitoring, what we can see, container failed, nothing. Okay, apps running. Yeah. Submitted, container allocated, idle, container reserved. What we just want to have, node status, input output. SDF is utilization. Okay, so memory. So in this particular cluster, the memory utilization is towards the higher side. So because of that particular reason, like we are not having the enough resources for this particular job, although like the small job is there, but the resource has been captured for that particular application. We can do the customization with respect to the resources. We have not like gone through with certain customization and all. We have just like mentioned created the Spark session and then executed the application. So because of that only it is taking too much time. What about the resizing hardware? So we have requested certain more hardware. Soon we will be having that, and then we will be able to do the execution. So let me, meanwhile the resizing is done, let me explain what we have covered in our today's session. Okay, so we have started with like how to create the Spark cluster the with with the command. Okay, previously we were creating a EMR cluster with GUI interface, but onto the Cloud Shell, we just type this particular command and we will be able to create that particular cluster. It is not like going through with each and every operation again and again. And in your organization, you just need to keep the things. You just copy the command and execute it, and you will be having the cluster that we have seen. Then we have seen like what are the different types of node: primary, core node, and task node. These are the three different types of node inside the Spark cluster. Primary, that is nothing but that is master of the cluster. Core node, inside the core node, like we will be having the capability for hosting the data and processing the data. But if we are talking about task nodes are not able to host the data, but these are utilized in order to process the data. Once we need to have heavy computation related stuff, at that moment we can have certain task node in our cluster creation. Then moving further, what we have seen: transit versus long running cluster. The transit cluster, like once the task is terminated, once the task is completed, then we are going to terminate the cluster. So that is transit cluster. But long running cluster, it is not terminated after the completion of job. These are uh, created for the longer duration. These are long running cluster. Then storage level, with respect to the storage level, we are having three types of storage level: instance store, and then S3 and EBS store. Instance store, it is tightly coupled with the machine or hardware. Once that particular hardware is terminated, then the data which is stored inside this particular instance store, that will be gone now. Although like we are having the benefit of data locality over here, but after the termination we will not have anything. Then we are having second storage level, that is S3. So with respect to this particular storage level, the data is available on S3, that is simple storage solution from the AWS side. And as and when required, it is moved. You can take this particular example. Say we are having the EMR cluster, and what we are doing over here, we are we are having the data and code onto the S3, and we are reading the data from S3, executing the code based upon this particular raw data and processing it, and finally moving it onto the S3. That is the simple example, and we are moving with that particular example only. And over here what we are doing, once the application is completed, then the cluster will be deleted or terminated. We will be having nothing, but the data will remain onto the S3. But this particular approach is having one issue, that the data is not locally available inside the cluster. As and when required, we just need to read the data from the S3 location, and that particular addition or reading the data from third party, or you can say another application, that or service, that is adding certain latency onto the job, and we can say the jobs are not performant at that moment. Then what will be the solution? Over here we are not having the benefit of data retainability. Data will not be retained over here, but and over here we are not having the data locality. So we are using a mixed approach, that is the EBS storage, elastic block storage. And over here with respect to the elastic block storage, that is network attached storage. Once you are going to terminate the cluster, it is going to ask like either you are going to keep the data or not. If you want, you can keep the data, or you can proceed for the termination. So that is the benefit what we are having inside the EBS storage. Then we have seen public key and private key. Public key, the that is utilized to transfer data between within the AWS, and once we need to connect the AWS from outside world, then the public key is required. So that's it what we have covered. Let me go into the cluster side. Okay, now for nodes are there, it has been failed, so it has been completed, and the previous application has been completed, and it has waited for certain duration and it has failed. Now what about this one, the thing what we are running on putty, so we are able to load the data. Now what we are going to do, we are going to load the another portion as well. Copy and load this particular portion as well over here. Okay, press enter. Guys, please go on mute. Go on mute. Okay, so the second portion is also loaded. Now what we are having the third portion of the data, that is processing the data. Let me try to process this and paste that particular code over here. Perfect. The processing is done. Now before the processing, let me and writing the output onto the disk, let me show you something. So we have done the execution. Now what is there onto the S3 side? Boost Analytics S3, and over here we will be having one folder, output folder, that is created at which time? 1216. Latest it was created at 1216, and what we are having, we are having the output in CSV format, and that is of around 1 MB. So this is the outcome what we are having at the at the S3. Okay, inside the S3 bucket we are having this particular outcome, and that is based upon that particular job. Now let me try to execute this particular job once again. Say Spark application and say cluster mode only, and copy that particular code, copy that particular file, Boost Analytics. Okay, before starting this particular application, I just want to show you testing code new and copy S3 URL. Okay, and over here inside the EMR I can paste it. I will just add it and the execution will start. But before that, I just want to do the execution over here, and final df.write, and I can paste it inside the putty. Okay, and the execution will be started. What is the issue? Trace bracket. Mm-hmm. Okay, duplicate column. So duplicate column, but it has been dropped with this particular. It has been dropped with this particular functionality. Found duplicate columns. Okay, Year, year is also duplicate. Output year. What is this? Year is also duplicate. Just a minute. Year is also duplicate. So I think because of that, like it was showing the error. And let me write it as well. So year is also duplicate in that particular data frame, and because of that particular reason, this particular job was failed. Now what I just need to do, I just need to remove the over here. uh, hmm, this is the file, and let me save it, close this, and let me check it, open with notepad. Here perfectly fine. And what I need to do, I just need to upload it onto the S3. I'm going to delete this, permanently delete. So previous file I'm going to delete, and I'm going to upload the new file over here. Upload the file that is testing new, and upload. That is perfectly fine. Close, and let me copy the URL, and over here inside the add step, Spark application, and let me try to add the cluster mode, the path, and add it. Okay, so this application was failed, and let me check the error. So it is showing the error as well with respect to this particular application. And exception em container, we just need to read it thoroughly. And okay, application exited with the failed status, error client message. Diagnostic user, or PC port. Let me check inside the cluster man UI, inside the Spark UI jobs, and we will be able to see the failed job as well. Okay, this is 3 Spark application 3 cluster trial, and trial 2 times, and we are just going through with the status. Let me first check the job ID. Okay, just have a look. Now it has been completed in 30 seconds only. Guys, are you able to see? Previously, the job which with this particular code, the same code, but what we have done certain optimization, like removed the unwanted stuff, and that was nothing much with respect to the optimization. You can think, you just see, like earlier it was taking the 17 minute, now it has bin executed within the 30 second. Now we further can you can say optimize this particular application. Okay, so that is what we need to identify. That is our job basically, in order to minimize the latency. If like job is certain jobs are taking too much time, we just need to understand that particular job, and we just need to do the optimization on to top of that, and then we will be able to get the outcome. So this job has been completed, and we are moving with, we just want to see the errors, and stay finished with the status jar view logs. We just want to see the errors. Hmm. Okay, so over here, like specifically that particular error which we were facing, that is not mentioned. Like that is because of the column name, like year column was repeated over here as well, and because of that particular issue, the code was failed. We are not able. Are you able to see? Class path contain repeated column error.
I can still
So.
find it by Control F if it is written here.
Uh, so what we can do the analysis based upon that the cluster logs as well. So this is the application which was running. Okay, and over here inside the cluster logs, application and the cluster log URL, I just need to see. I just need to go onto the S3 and AWS. I just need to go on S3. Okay, so what we are able to conclude over here, we are able to do the execution of our Spark job onto EMR cluster. So this is the EMR cluster logs. November 6 7697. Is it the same? 97 ended with 497. Okay, perfect. So over here we will be able to see the clusters basically. No, that is not the same. Buckets, northeast 27497 east. Which one we just need to read? EMR map reduce US east one, east one. Hmm. Elastic map reduce. We will be able to see clusters over here. And which one is our cluster? 3U. 2103 ended with 3U. 210 ended with 3U. This is the cluster that we have created. Then container, then steps. We are going to see. And now which step was failed? I think MVL. This is the step that was failed. Let me check the step which was failed. So JYK ended with JYK. Ended with JYK. This is the step, and then controller logs. Okay, so mhm, nothing in this. Then steps, standard error. Over here as well, we are not able to see, but somewhere we
Sir,
will be able
in the
to.
previous file, there was a error keyword somewhere in the previous file.
Container, huh?
Yes, sir. That,
Mhm.
yes, sir, here redirected error.
No, but I am looking for the specific error, because of the column name.
Okay,
Okay,
okay.
so that is not given explicitly over here. If we are running, it is in cluster mode. If we have, if we would have run it inside the client mode, then that particular error we will be getting. Okay, that is the difference. Say towards the client side, you will be able to get more details of errors once you are running in client mode. Okay, so errors are not there, but the main thing is that we are able to do the execution of our Spark job, and we are able to run it onto the EMR cluster. Now, just I want to show you something over here. If you are looking onto this particular command, what is the command over here? Just have a look. Spark submit, and Spark submit or deploy mode client, or at this moment deploy mode client is there, and over here we were having deploy mode cluster. Cluster deploy mode was there. Okay, and in the previous one as well we were having deploy mode cluster. So deploy mode cluster. Okay, so let me copy this. So this was having issue, this was failed because like we were having year, that was the repeated one, although like we are not able to see the errors thoroughly, but that was because of that only. If we over here, if we are able to see the errors, error should be there, that error should be there because we have done the execution in output, controller syst output, just a minute. Okay, it is not it. Once the system output is available, we will be able to get the exact error. System output, it will take certain time. Once the system output is available, it is generating, a star is coming. So once it is available, we will be able to get the exact error. That is because we have run it inside the client mode only. Because of I have verified it, so this particular application was failed, and the deployment was cluster mode was there. So just wait, probably inside the this particular standard std output we will be able to get the issue why this particular job was filled. It will take some time. It will be available, and then we will be able to get the details. Okay. Now, what I was explaining, this is the mode or method in which the Spark application are being executed onto the cluster. Spark hyphen submit hyphen deploy hyphen mode. Then we just need to mention, is it the client mode and cluster mode? Then we need to mention the location of our Python file. This is the location of our Python file, and it will be executed onto the cluster. And previously, what we have seen, like this particular application was taking too much time, and now it has been executed within 30 seconds only. And that is because of certain optimization what we have done, and increased, as we have increased the resources as well. From 2 node to 4 node we have done over here. Previously the cluster was running with 2 core nodes. Now we have increased it to 4 core nodes as well. So we are able to do the optimization onto two levels, the code level and onto the capacity level as well, or what we can say hardware level. So that's it for this particular session, and we have gone through in detail with the different aspects of our applications, how to run it onto the EMR cluster, and probably you are going to create the EMR cluster. But what is the thing that you need to keep in your mind after performing your task? Just don't forget to terminate this particular cluster. So terminate it, and and if you are not terminating, then you just need to pay heavy price for that. Okay, so that's it for this particular session.
Sir, in free session
Anything?
also, sir, in free session, if we did not terminate, then also we pay.
Come again,
Sir, I'm saying
please.
in free edition. Here we.
Actually, certain services are free, but after that, like say, it is there for 2 hours on daily basis. But if you are using it beyond 2 hours or more than 2 hours, then you need to pay price. Or EMR related services are not free, right? EMR related
Okay.
services are not free. So it has been terminated, so we can close it. Let me